Next problem is integration 0 to 2 x power 4 plus 1 divided by x power 4 plus 2 whole power 3 by 4 into dx. Now we assume this one as I, integration I 0 to 2 x power 4 plus 1 divided by x power 4 plus 2 whole power 3 by 4 into dx. Now in this integration we will do I equals to 0 to 2 because this side numerator and denominator looking similar only. So what we can do, in numerator we can add plus 1 and subtract minus 1. So what we are doing, x power 4 plus 2 minus 1 divided by x power 4 plus 2 power 3 by 4 into dx. So now we can do separate. So I equals to, we can do 0 to 2, this will come x power 4 plus 2 whole power 1 minus 3 by 4 minus integration 0 to 2 1 upon x power 4 plus 2 power 3 by 4 into dx. Now there are two functions. One is integration 0 to 2 x power 4 plus 2 power 1 minus, so this will become 0 to 2 x power 4 plus 2 power 1 by 4 into dx minus 0 to 2 1 upon x power 4 plus 2 whole power 3 by 4 into dx. Now here we will use I equals to, we will use here pi parts, so dot 1. So x power 4 plus 2 power 1 by 4, integration of 1 is x 0 to 2 minus 0 to 2 integration x power 4 plus 2 power 1 by 4, differentiate 1 by 4 into x power 4 plus 2 whole power 1 by 4 minus 1, then inside differentiate 4x cube into integration of 1 is x into dx. So I equals to x power 4, I equals to, if you put 2, so 2 power 4 is 16 plus 2, 18 power 1 by 4 into 2, 0 if you put 0, minus 0 to 2, 1 by 4 as it is, x power 4 plus 2 is from 3 by 4, 4x cube, so 4 into 4 I think getting cancelled, so this is getting x power 4 into dx, this is minus 3 by 4. So I equals to 2 into 18 power 1 by 4 minus 0 to 2, this is problem x power 4 divided by x power 4 plus 2 power minus 3 by 4 into dx plus 3 by 4, and this remaining portion, this portion is, you can write here, minus 0 to 2 1 upon x power 4 plus 2 power 3 by 4 into dx. And similarly here also if you write same problem, 0 to 2 1 upon x power 4 plus 2 power 3 by 4 into dx. And similarly here also if you write 0 to 2 1 upon x power 4 plus 2 power 3 by 4 into dx. So I equals to 2 into 18 power 1 by 4 minus, if I take 0 to 2, this will come x power 4 plus 1 divided by x power 4 plus 2 whole power 3 by 4 into dx. This is nothing but I, so 2I equals to 2 into 18 power 1 by 4, so I equals to 18 power 1 by 4. This is answer. Next problem is 0 to 2 pi e power cos theta cos sin theta d theta. So this is also interesting problem. We know here we will use complex number. E power iota theta we can write as cos theta plus iota sin theta. So here real part of e power iota theta we can write as a cos theta. So similarly in this problem we can write 0 to 2 pi e power cos theta, and this thing we can write e power real part of e power iota sin theta d theta. Now for simplification 0 to 2 pi, because e power cos theta we can take inside, e power cos theta is real number only, so real number we can take inside also in multiplication, so we can write real part of e power cos theta plus eta sin theta d theta. So 0 to 2 pi, real part of the e power cos theta plus eta sin theta, we can write e power eta theta d theta. Now 0 to 2 pi, we know the e power x expansion 1 plus x square by 2 factorial plus dot 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 dot. Similarly in this one e power, this is e power eta theta is work as x, so 1 plus e power eta theta plus e power eta theta whole square divided by 2 factorial and so on, and this is real part. So 0 to 2 pi, this is d theta 1 into d theta plus 0 to 2 pi, real part of e power eta theta plus e power eta 2 theta divided by 2 factorial and so on. Now in this one, this real part of e power eta theta is cos theta, then cos 2 theta, so this function is periodic and function is cos theta cos 2 theta. So in the interval 0 to 2 pi, this becomes 0, so integration will come 0 to 2 pi 1 into d theta, so this is theta 0 to 2 pi, so what will answer 2 pi minus 0, so 2 pi is the answer. Next problem is in equals to 0 to pi sin square nx divided by sin square x dx. So this problem you have to solve. So in this problem we can see in equals to 0 to pi sin square nx, we can use cos formula. We know sin square theta equals to 1 minus cos of 2 theta, so there you'll use this formula. Sin square n theta is 1 minus cos of 2nx, because theta is nx, so 2nx divided by 1 minus cos n cos 2x into dx. Now to solve this problem, we will do in plus 2. So this is 0 to pi only, 1 minus cos 2nx, because if I put n equals to n plus 2, so denominator will remain same only numerator will change. So 1 minus cos 2x remains same only, then plus 1 minus cos, instead of n you will put n plus 2, so 2n plus 4x into dx. So in this one in plus 2 equals to 0 to pi, this will come 2 minus cos 2nx plus cos 2n plus 4 into x into dx divided by 1 minus cos 2x. So 0 to pi 2 as it is minus cos c plus cos d formula, 2 cos c plus d, 2nx plus 2nx plus 4x divided by 2 into cos c plus d into cos c minus d. So 2nx plus 4x minus 2nx divided by 2 divided by 1 minus cos 2x. Here we can use brackets, here also bracket. So in plus 2 equals to 0 to pi 2 minus 2 cos, this will come 4nx plus 4x divided by 2 is 2nx plus 2x into cos 2nx getting 4x, so this will come 2x divided by 1 minus cos 2x into dx, here also dx. So from here we can take 2 outside, 0 to pi 1 minus cos 2x into cos 2nx plus 2x divided by 1 minus cos 2x into dx. This is in plus in plus 2. So next is in plus 2 equals to 2, 0 to pi. 1 minus, we will add and subtract 2nx plus 2x plus cos 2nx plus 2x minus cos 2x into cos 2nx plus 2x into dx divided by 1 minus cos 2x. So this one gives 0 to 2 pi, 0 to pi, 1 minus cos 2nx plus 2x as it is, in bracket close. And in this one we can take plus cos 2nx plus 2x, in bracket we can write as 1 minus cos 2x into dx divided by 1 minus cos 2x. Now if we do separate, this will come 2, 0 to pi, 1 minus cos 2 if we take outside, n plus 1 into x divided by 1 minus cos 2x plus 2 times 0 to pi, 1 minus cos 2x, 1 minus 2x getting cancelled, cos 2nx plus 2x into dx. Now this thing we can add in plus 2 equals to 2 times, this is nothing but in plus 1 plus 2 times 0 to pi cos 2nx plus 2x, it will become 0. So this is 0. So from here we can say in plus 2 and in plus 1. We can say in plus 1 and in plus 2 are in AP. So we can say I0 n equals to 0, we can say I0, I1, I2, I3 dot 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 in are in AP. So I0 we can find out 0 to pi sine 0 is 0 into dx. So this is integration of 0 to pi 0 is 0. I1 we can find out 0 to pi into sine square x divided by sine square x into dx. So 0 to pi 1 into dx. So this is answer is pi. So I1 equals to pi. Similarly I2 if you want to find out, so 0 to pi n equals to 2 sine square 2x divided by sine square x into dx. So here you will use sine 2x formula. So I2 equals to, we can write as 0 to pi 2 sine 2 square is 4 sine square x into cos square x divided by sine square x dx. So where sine square getting cancelled. So I2 equals to 0 to pi 4, you can take outside, cos square x into dx. So here we'll use property. If I give 0 to 2a fx into dx, we can write 2 times 0 to a fx into dx if f of 2a minus x equals to fx. So here we can write this one, because cos square x, cos pi minus x is minus cos x, because of square it will come cos square x only. So I2 you can write as 4 into 2 times 0 to pi by 2 into cos square pi minus x into dx. So this is I2 equals to 8, 0 to pi by 2 cos square x into dx. Next is the next one more property is there, that is if I write a to b fx into dx, we can write this one as 1 by 2 a to b fx plus f of a plus b minus x into dx. So this property we can use in this one. So I2 equals to, we can write as 8 into 1 by 2 0 to pi by 2 as it is, cos square x plus cos pi by 2 minus x square into dx. So this will come out I2 equals to 4 0 to pi cos square x plus sin square x equals to 1 into dx. So oh sorry, this is pi by 2. So I2 equals to will come 4 into pi by 2. So this is 2 pi. So I1 equals to pi, I2 equals to 2 pi, then common difference is pi. So In equals to A plus n minus 1 into d is pi. So this will come n pi. This is your answer.